Hello and welcome to the Mythruna weekly live stream. Tonight we'll be diving into a little bit about random number generation, and I'll start on settlement placement since the rivers and lakes and stuff are far enough along that we can start using those to factor into where settlements would and towns and stuff would likely generate. Yay! All right, so thanks to my patrons. It's kind of important right now, actually, because we have a lot of medical expenses at the beginning of the year and stuff, and the Patreon money lets me keep my servers running and stuff. So it's really cool. Thank you so much for everyone who even gives just a little. It means a lot. And so without further ado, we'll run right in. I will point out that I believe you guys should be seeing in the upper left corner the super secret URL for the download and the password. So if you happen to be paying attention, you're on the live stream, you should be able to download the last version of the game that I released, when that was January or so. All right. So what I'm going to start with is talking about pseudo random number generation and performance improvement. This is a picture of the plateaus from the engine. I really like them because I feel like they add a lot of scale to the world. To me, they look farther away and bigger than mountains and things, which can be deceptive in that they might look like hills. You can't really tell how far away they are, but for some reason the plateaus just have a level of detail that to me makes them look far. Like that looks to me better scaled than that, even though they're really about the same distance. This could be a hill, in fog. It's tough to say, but that definitely looks like a plateau. The sort of basis for this is cellular noise or Worley noise, and I have pulled up a pretty good website if you want to check it out. The Book of Shaders.com/12, but it talks about what cellular noise is, and we'll go a little bit into it. But the basically it takes points. It takes points and calculates like the distance to the nearest point, and so like this line, I can't really point to it without disrupting the visualization. Do you have a build you can drop into? Looks so good. What do you mean, do you have a build I can drop into? Like to look around? Yeah, I mean, I'm going to show that stuff later if that's what you mean. Anyway, so like what they're explaining here is that for each cell, you kind of determine the distance to the nearest points, and so you get these sort of lines in between, which are kind of like the point where this. I wish I could point without using the mouse. Anyway, you get these once you've. Yeah. Once you. Whoops. Oh, that's kind of cool. That site's really neat, by the way, because it's live and interactive and stuff. Hey, I know what I can do. Here, what I'll do is I will take a screenshot. That way I can point at it without it moving. So each of these, there's basically a sort of point in here, a point in here, randomly generated points, and then the algorithm calculates sort of the distance to the nearest point, and that's why you get this these sort of lines here where this was the nearest point, and that's how far away where we were from it, and then this over here became the next nearest point, and so it creates this nice these sort of cellular structures, and they're really good for cracks in the ground or all kinds of really organic things. As we scroll down here, it kind of gives you some examples. But the core part of it is you divide your space up into these grids, and then for each tile in the grid, you need to come up with a random point. That's sort of the Worley noise idea. And then so then you can calculate the distance between those random points. So the fundamental part of this is what we'll come back to in a minute, is given a cell, let me find a random number in that cell. And usually what you do is you sort of think of integers. So this is 1, 2, 3, 4, and then these would be the fractions within the integers. So you randomly generate a point, that's a fraction of an point, 0.001, whatever. And so you have to do this in a really repeatable way, because if I asked for this point again, I need to get that same point for this cell. So it's random, but it's repeatable random, similar to fractals, except for this is like truly random. We don't want neighboring cells to be similar or any of that stuff. They're kind of talking about how that's calculated here, and how so to calculate the Worley noise for a given cell, you actually have to check all of the cells and figure out the closest one, and that's how, because we could be closest to this point over here that's in a different cell than we're in, and so on. So first you generate these, and then you check all the neighboring cells. And so you can see, just to figure out, if I decide, like this pixel here, if I want to know what's the closest point to that pixel here, I need to have calculated those random points for all 9 of these cells. So whatever expense it takes to calculate this random point, I needed to do that 9 times. And so here's one that's kind of cool, because it shows the points in motion. And so you can really see the cells and stuff form. Here's another one. If I move in, you can see. But this is kind of the basis of these cracks that form. And I, of course, layer a bunch of things in, and I layer cracks in. I layer the plateaus themselves are, these in here, at a certain distance from the point, I cut it off. Let me do this again. New. So like for the plateaus, I actually invert this and I calculate a distance from these edges. And so I decide, at a certain distance from the edge, I chop it off, and that becomes plateaus. And then whatever point this was on, that's where I sample the fractal for the elevation. So all of these within this would get that same elevation, which is why they're flat. And so that makes the plateaus. And then I layer on something else that cuts out the cracks, and there's actually several layers of this stuff. So it gets really expensive to calculate all of these random numbers, each of these. And so there's a random function that's used. Random2 is what they called it in this, and I originally called it that as well. Here's another one that's kind of cool. But you can create some really cool stuff with this, and so it's a very thing. And of course and this is the one that I have, like the 3D cellular noise. Anyway, really organic stuff. And so it was really important to me to have this kind of terrain, because it just looks different than any other Perlin noise based terrain you will get. And so having this spotted throughout the world was kind of cool, but it was also really slow. It would take for a particular scene that I was using a lot, if I just loaded from scratch with new data and ran the game, it would take 3 minutes and 40 seconds before it had resolved all the far terrain. And if I got rid of the plateaus, it would take it just over 2 minutes. So it was a significant expense to calculate all these. And so I spent some part of the week diving into what was making it slow. And it turned out to be the random number generation that was those cells. And I'll go back up here so we can, it turned out to be this random2. And let me jump over to, where's my PRNG stuff? Am I looking in the right place? Yes. So I did a bunch of stuff. This was my original, and this is in Groovy because I was testing it in here. Yeah. So this is a scripter tool. It just lets me run some Groovy scripts and generate textures and things so I can try different algorithms out. And so it made a good test for that random thing because it uses Worley noise. Huh. Okay, so like here's one I was using to test normal maps, basically making sure that my normal maps projected out instead of projected in. But in the, let's see, let's go in here and I can, get rid of that. So let's put the, PRN Voronoi, which is sort of the thing. So see, this looks very similar to that texture we saw down here, right? These, it's just a zoomed out version of that, and so that's cellular noise at its most detailed. What I did was ran through some profiling. That was less than helpful. What I ended up doing is going into the base of this sort of cellular sample stuff and just commenting out parts to see what was taking a long time. The sign takes a long time, so I looked at that. It turns out these modulo operations, even the modulo 1, were taking a really long time because they're divisions internally. Before I really understood what was going on in the algorithm, I did some classic optimization stuff, like I tried to turn the sign into a table, so like a lookup table, so that I didn't have to calculate sign. But it turns out, because we're dealing with the fractional parts of these numbers, let me go back over to this diagram. Because we're dealing with the nice, cool. You should definitely check out the bookofshaders.com site. It's super cool. Lots of neat stuff here. Hey, how's it going? So, so we're dealing with the fractional parts of this, and I actually looked up the origin of this particular random 2 implementation. This was the original one that I borrowed from the shaders that we just were looking at. And the thing is, if you sample sine at a high enough frequency, it looks like noise. And if you're grabbing just the fractional part is very noisy. And what we were doing was we were taking that fractional part and using that as our sort of cell thing. When I turned it into a lookup table, I was approximating sine, which if you need to use sine for actually its use case, that would have been fine. But we wanted the smallest part of the fraction, and I was basically eliminating that. So the table version didn't work at all. It created very general, it looked like a grid. So that was not working. So anyway, I looked at other options and I was like, well, maybe there is a way to do random number generation that doesn't even use the sign. So I pulled that apart. I looked into other forms of random number generation because my requirements are not the same as like cryptographic levels of randomness. I just need something that's pretty random. And so I created a test that would run, let's see, it runs a lot of samples. So, I mean, you can see it's generating a bunch of stuff. And Massive Breaker, there was some of my other videos, live streams early on, that had like a deep dive into some of the fractal stuff and how I combine the Perlin noise and stuff to make some of the other terrain. So what this is my version of the function sampled. Essentially what I do is I, over some large area of a pretend map, I ask for the those fractional, these locations, and then I plot them on this big square. So this little dot was a fractional part, this little dot was a fractional part, because I'm looking to see how random they are. You can see there's some bands in here where it gets thicker. That's sort of an issue with my algorithm, that there's some areas that get more frequent than others. If we go back to the original, let's see, we can say use the shader approach, which is going to take longer to generate, obviously. Yeah, so this one took 19 seconds. The other one did. We'll see how long this one takes. It's going to take a little longer. But this was both a way to make sure that the product of my new random was, for one thing, covering all the area, and for another, that it wasn't bunching up in specific places. And so this is really random, although you see some banding here as well. Like if we take a screenshot of this and then put mine back, and so then we get, let's see how long that one took. That one took 27 seconds. Yeah, so 27 seconds for this, for the slow version, and roughly 19 seconds for my fast version. And what we're doing is we're sampling, like, we are pretending to go over a map that is 4,000 by 4,000. So we're sampling 4,000 by 4,000 times, and plotting all of those values. And so we see, if we take this one and take a screenshot of that, and then go here, and start. So if we look at those two, so this is my random, and this is the book's random. This is the one that's got the band that runs through the middle, and mine, which has these bands. You can tell that mine is less noisy. Like we've got like these bands, but it's noisy enough. What I ended up doing was taking, basically I pre-calculate a big table of random, trying to eliminate all my divides and things. I calculate 65,536 random values, just the random longs, so it's 64 bits of randomness per entry in this table. Then for each, when I ask for the X or the Y, I just basically hash those X, Z values in some arbitrary thing, so that the same Z and X would, if you swapped Z and X, it would give you different values, that kind of thing. And then use that to index into this table. Also no divide, because I did a bit mask for the table index. So I get one of the samples that we got, and that on its own is not super random. If I take this out, like we'll see, if we just get the sample, and yeah, down here basically I chop off the lower 53 bits and multiply that to be between 0 and 1. So this should be a little faster. I'll actually look at the time this time. So yeah, that was 1 second faster, but you see this is not very random. It looks like plaid, right? You can see things bunching up very. So what I did was I added these rotate right. So it takes the, those random bits we got out of the table, 64 random bits, and it shifts them by the lower order bits of X in this case, and lower bits of Z in this case. So it just adds some extra randomness, because these long bits are already random, and we're just rolling it by whatever spatial noise happened to be in the lower order bits of X. So that X equals 1 would be slightly different than X equals 2, and they would rotate right different. Rotate takes the bits off of one end and puts them on the other as it rotates around. So if you imagine this is one big giant bit stream, in fact it is, right? If we rotated right once, it would move everybody to the right, take this one off the end, and put it back on the beginning. And so by rotating, really I never really anything more than 64 is a little weird. But so by doing that, we add additional randomness to the bits, and it helps a lot. This actually surprised me that it worked. And so then I took this and pumped it back into the Voronoi texture, and it obviously worked because let's go. Why did it not change? Maybe I need to reset this. Yeah, it thought it already ran it, that's why. So this, and if you look, I mean, this is plenty random. If you look at the original, which is slower by a little bit, you know, it took a 0.3 seconds longer, but, you know, it looks pretty random. That's the original. Let me, and we're going to fix, and this is the change. And you'll see the data is different. That's to be expected. There, we're getting different random data. That's to be expected. But the, you know, the general randomness, you see the cells, they look uniform. You know, they're random, and these are the two. This is the oops. So you see there's different random, but the distribution's about the same. They look very similar as far as frequency. So I was happy with this. Factored it into the world. Of course, it moved around all my cliffs and stuff and pointed out some other issues. And since I had a request, I'm going to jump into the world. And we can look around a little bit. I explored a little bit because I did find some initial problems that I was worried were the cellular noise, but turned out to be bugs in the actual fractal itself that just hadn't hit the right random situation to cause an issue. That is one sort of issue with random worlds, is when you've got all these different fractals and random algorithms layered on top of each other, it's literally impossible to test all the different edge cases. And so every now and then you'll run across some strange thing, and then you have to track down what's causing it. And so in here, we're in the middle of a sort of subtropical rainforest here, which I wanted to go check out to make sure it was still here. And so you got mountains off in the distance over there, and then the plateaus off over here. But because I have this cool marker tool, I can find places. So let's find. I need to delete some of these. They no longer apply. Let's go to, which one was it? Big Lake. So if I warp to Big Lake, and then we can freeze my user interface for a minute. Hopefully I didn't freeze the live stream too. So anyway, so if we look at the map, so we can see when things are generating in. So, you know, I spent a lot of time messing with the bodies of water. You can see on the map. And I think even though there is some variation, I'm going to add eventually larger variation, because a lot of the lakes, the generated ponds and lakes, look really round if there's not enough terrain around them to, but I still think it looks really cool. So this is a lake, generated lake with the river that fed it. And in fact, if we jump up here, you can see the river off in the, you know, trailing off into the distance, which I think is kind of neat. The variation of the coastlines does do some cool things. Somewhere over here, we get a nice little, inland lagoon kind of. It's this is a little pond off to the side of the thing. If we run over here, yes, absolutely, random name generation. In fact, I already had that in an early version of the old engine. I'm going to do something a little more advanced this time, but the tricky part town names is pretty easy. The tricky part is I want to come up with cool names for like the forests and stuff that make them sound like, fantasy forests. Since I can detect regions that are forest and, lakes like this, even the ones that are just generated because the water level or the land happened to dip below sea level. In this case, we're above sea level by quite a bit, in fact. Though the lake does dive into sea level. At any rate, yes, random name generation. There's even random name generation for NPCs already. So, as you can see, some deserts, and I'll show you the problem area that I had to deal with. Although I fixed the problem. So, well, first of all, we had one that was odd ridge. That actually was an algorithm problem in the lake generation stuff. Oops. So here we are in the frozen tundra. And I spawned underneath the ground. Oops. So when I originally generated, there's this big ridge that formed back here because there was a bug in how the terrain fall off went. Look at that ice. So here is and of course we're having trouble. I'm moving too fast for the generator to catch up. Because I know the secret keys. So here we've got like a round, crater style lake. It's going to be fed by some river. Yeah, here's the river over here that feeds it. So kind of cool. Oh, another river over there. Oh, fading out for the distance. There's issues with the generated water. Has some border issues with the far terrain. These are things I'll fix later. We got and then the place where I had problems with the fractal, that would be, warp, sheer cliff. So if we look at so that wasn't too far away from where we just were. Uh-oh. Again, I spawned beneath the ground. The used to be right here. This was a sheer cliff, like literally vertical wall, which my far terrain doesn't like too much. It wants a little bit of slope or it creates really weird artifacts. And so I went back and I figured out why that particular thing. But the other issue was, and where is an example that I can find? The cracks. There were places where the land was shooting up through the cracks and making these really thin walls. And I was able to eliminate a lot of it, but it still happens here. You can see these very thin areas. I think it's worse over here. No, where is the good example? Oh, this is a pretty good example right here, right? We've got this crack generated a ridge, like almost a 1 block wide ridge. There's another one over here, these sort of walls. And so, this is actually just a product of the math in that what feeds these ridge fractals that are generating these spiky bits, so that they look like they vary with the terrain, the elevation factors into the fractal generation. So each elevation is basically sampling a slightly different area of the fractal. And most of the time they're near each other and they'll be similar. But when you have very deep cracks next to, sort of flat land, the deep crack may sample a part of the fractal that's very bumpy. And the other part may sample a part of the fractal that's smooth. And that's what's happening here. And I kind of muted it a little bit just to prevent some really crazy stuff. This is okay because this ridge is pretty wide. But at any rate, So that I spent some time figuring that out, and so I was in the mapper tool again, messing around. But these, just, I mean, it generates really neat terrain though. And so at some point, again, I can't plausibly explain why that would happen in real life, but it's not so strange that it draws. And maybe there is a reason. Maybe some ancient civilization had carved out part of the mountain. I don't know, but at any rate, again, the mantra: lean into the randomness. Don't try to force too many rules on things because you'll make boring, and you can't solve boring. A rare occasion of these kind of weird things, I think, is kind of cool. And in the end, kind of, if you find something strange, you get to take a picture of it, and maybe no one else has seen anything like that. And that's kind of a cool idea. At any rate, so this is the terrain. Hopefully that satisfies your need to see it, Ron. And we can kind of get past the fractal issue at this point. But yeah, I love walking around and exploring. There is a sort of lake and streams and stuff around here, which was fun to follow. But the sunset went a little faster. We could watch the sunset. Here we go. Here, I'll speed the sunset up so we can all watch the sunset together. There we go. And the sound even changes. Okay, so yeah, that was fun. Oh, you got this. Oh, the moon. Hello, moon. All right. So, okay, enough playing around. I waste so much time wandering around in worlds that'll never generate again. It does make me feel a little bad sometimes that I get to see things that, it's kind of cool too. So anyway, that's what I did. I basically optimized the randomness. I made a spreadsheet of so for a given, I made a terrain test that generates this area of the world, and that has some amount of regular fractal terrain and some amount of the cellular noise that makes those plateaus. And it's big enough that it would take a long time to draw. If I did it with no plateaus at all, that tile took 6 seconds or almost 7 seconds to generate, right? If I used the old algorithm with the regular original RAND 2, that did all this stuff, that took 33 seconds. It's a long time. Considerably longer than no plateaus at all. And that's what was frustrating. If you had plateaus on, then terrain always took long to generate. So I did some other simple optimizations of that algorithm, and I was able to get it down to just about 16 seconds. But then when I went to the table-based PRNG, the pseudo-random number generation that you guys just saw, I got it down to 9.8, which is just about 3 times faster. It takes about a third as long, depending on how you want to call that faster. And it's only 3 seconds faster than not having plateaus at all. And frankly, for that size tile, I'd pay 3 seconds for plateaus because I think they're cool. So, and they'll be really neat when caves are generated and stuff. So anyway, that's how it broke down and my big success for the week. And I was really excited because I actually went to websites and did research on pseudo-random number generation and learned some things that I didn't know before, and took apart how Java does its and some other fast implementations. The key thing for me, though, is I can't just ask for random numbers like a regular random number generator. I have to be able to give it an XY and get the same number back out again later. So that made it for an interesting sort of algorithm. And so I feel like it's solved at this point. So what are we doing today? Half hour into the live stream. How many do we have on today? Seems like, oh wow, 5 concurrent viewers. Nice. Okay, so here we're back in the mapper tool, and going to mess around with, that's just a pretty view. I should put together some desktop images for people maybe. I used to do that with the old Mythruna engine. So yeah, I'm zoomed way in because this is the same area of the world that I was having problems with, that I was just talking about. Let's generate so that it's consistent. Where there was a sheer cliff right here, and now that's smoothed out, and those spiky areas were coming up through the cracks, and so I was able to get rid of that. What we see now is, so let's talk about town generation. What we want to do is similar to how we found, good places for rivers to start and good places for rivers to flow. We kind of want to think about the demographics, well, I use demographics, the characteristics, let's say, of different points on the world, and decide, what confluence of characteristics would make a town more likely to appear. So you end up sampling, and I'm trying to use the same sampling distance that I used for rivers and other things, because obviously if I can generate that data once and reuse it, it's useful. And in fact, the Sodectile, these 16 by 16 kilometer by 16 kilometer tiles that I generate data for are using 128 meter samples, and they sample everything about the fractal, the precipitation levels, the average temperature, all that stuff, and they store it. So if I can reuse that, it'd be great. But my experience has told me that probably 128 meter samples are too far apart to really get some of the things we want to know. I have the advantage this time around that I will, at least by that point, know where forests are, know where bodies of water are. That's already something I've calculated. But so anyway, let's talk about how this ends up working. I started a little bit before the live stream, which is why you see all these blue points. These were basically 128 meter samples, like I said. So that's the settlement data. It samples 128 meter points, but I've set it up so that I could change the spread to something else if it looks like 64 meters would be better. That's what I used before, I believe, when I did this algorithm in the old prototype. So we have this here. We can so we build these like cells. We can sample different things about the cell, just like we did for the Sodectile data. So let's say we wanted to know, well, let's look at what bioinfo collects, because we'll probably just want to grab everything that, let's see, what are the different things we can ask for about the fractal? We can ask for all these different things. In fact, I believe World Fractal has a method to ask for the bioinfo. Yeah, so let's just do that, and we'll cheat here. We'll put bioinfo bio. Gonna fail? Yeah. So we don't have that imported. That's going to be put that up there for a second. Let's, yeah. Okay. All right. So when we make the cell, we will grab bio equals fractal. We will grab the biological information for that. I couldn't think of a better word for the data associated with a particular point in the world that samples the fractal. So we want the X, Y, and Z, and I think I can do null here and it'll make a new one for me. Yep. Okay. So we sampled our data. I did this in 2 separate scripts so that we can sample it once and just keep drawing it over and over again. So if we wanted to, we could say, like, I'm going to pull over. My trick is to, so I don't have to switch back and forth all the time, since I don't use an IDE that lets me do quick kind of stuff. Coming up with names is a pain. Yeah, but super important. I tell the story about a guy I used to work with who had an open source package, and he came in. He had the open source graphing API, and he came into my office one day, and because we started a conversation. Yeah, I could randomly generate the. Yeah. He came into my office because he was having trouble coming up with the name for a particular method on his class, and that led to like an hour-long conversation. And he was disappointed when he walked out because he realized that the reason we were having trouble naming that particular method was because there was a fundamental shift that had to happen in the API. And so we came up with some cool ideas, but he was a little disheartened that he had to go rewrite a bunch of stuff, or he wanted to, right? We were engineers. The better solution was to rewrite a bunch of stuff. Anyway, I'm going to cut and paste these over here to give myself a reference for everything that's in that bio. And so we can take this and we can say, maybe we want to have different colors for different things. So let's make gray the default color. Let's make sure gray is the one I want. Yeah, so gray would be pretty boring. And so let's say if I'm trying to remember, these are all in 0 to 1. So if the cell.bio.temperature, there are 2 hard problems in computer science. Yeah. So if the cell temperature is less than, I think this is how I had it set up. I'll look up the real temperatures later, but I think it's 0.857 and anyway, whatever. We'll set it up to be if things are above 0.9. So if they're below 0.1, we'll set the color to, let's set the color back to our cyan, which was a nice color for ice, right? And then if it's super hot, we'll set it to red. Let's see what happens. Yeah, so we got some red areas off in this. Yeah, so here's our icy tundra, some mountaintop cold. So anyway, you can see that we're sampling the points. Yeah, so we got a bunch of desert over here. And so we're starting to get information about areas. So another thing we could do would be to sample areas around us and decide, let's change the desert to yellow. So that, yeah, it's a little better. And then any place, while we're here, yes, if the cell bio, I think vegetation level is the one where if it's greater than 0.5, that's like serious forest. I have to check here. Yep. Yeah, so we got this area here which is like hardcore forest. And when I took that picture earlier, I was on one of these hills. When I call it the Green Heart. It's just a big subtropical forest. So anyway, we see we've got information about these samples, and you could just basically we iterate and we keep adding things. The other good thing to have is if you x equals -1, x is less than or equal to 1, x plus plus. So what do we say? Ix equals I plus x. Jz equals j plus c. If ix is less than 0 or ix is greater than or equal to work count. Basically, we're clipping. Make sure we don't go over the edge. And JZ. So we're sampling all of our surrounding points. Here we can also say if x equals 0 and z equals 0. So we're not sampling ourselves. I end up writing this loop so often. So, you know, for any given cell, we'll look at all of our neighbors, and we can do stuff with those neighbors. We can see if our neighbor is in the water, which means we're coastline. We can see if our neighbor is higher or lower than us, which means that probably we're cliffside. And that's one thing that's super important to know. So let me think how. Let's say we want to just do cliffside. So we want to collect up cliffs equals 0 and down cliffs equals 0. So if our neighbor, if settlement data sub ij dot loc dot y. Okay, what is the threshold? Let's see. Cliff threshold equals, what would be the difference between, so let's just pick 40 meters for now. So we only have to check this once. What is our cell.loc.y minus that? So ours is greater, then delta will be positive. We are up cliff. If delta is greater than cliff threshold, we are up cliffs. And else, if delta is less than negative cliff threshold, down cliffs. Okay, so we should know basically at this point if we're on top of a cliff or on the bottom of a cliff. So let's say if up cliffs is greater than 0, let's set our color to red and see what happens. So do we get any? Yeah, that's a bad sign. Let's change the threshold to something small so we can see small-ish. Yeah, so I think there's something broken in my particular check here, because any one of these should have triggered that. So I've done something wrong. Oh, I know what I did wrong. I'm not using the right location. Yep. And why didn't these then change? Oh, up cliffs I set to green, that's why. There we go. Okay, so let's set our threshold back to 40. Yeah, so we've got these guys who are on top of cliffs. And let's, what do we want to use for the color of stuff? If down cliffs is greater than 0. So eventually we want to kind of mix these colors together, because they're all kind of happening at the same time. In fact, let's do this differently. Let's say if we're up cliffs, we'll add a red tick but slightly offset from the other. So 10, 0, 0, 10, 0, 0. And if we're at the bottom of the cliff, we'll use like pink, I think is, and we'll make that -10. So we allow both at the same time, and really we don't need this part up. Whoops. These can be shorter than they are. Okay. All right, so we've got these cases of cliffs, and here's kind of what I want to talk about. Oh no, these turned out okay. So here's a place, right? We've got stuff that's up at the top of the cliff, stuff that's up at the bottom of the cliff. And so if we want certain kinds of points of interest, or, you know, like for the avian people, they're only ever going to live in ruins that are set up at the tops of cliffs, and so we can know where those kinds of ruins will happen. And because we're, you know, making parallel marks now, we can still have desert, and we can have all this stuff show. And so we just iterate on this kind of thing. The other thing for town placement, there's a second pass that happens where you build in the characteristics of all these different places, and then you project out, and you so let's go back over here to one of our cliffs, right? So the town's probably not going to form right here on the cliff. It's going to form nearby that. So if you have this case where there's a down cliff here where a mine might form, then we make a pass that we go through, and we increase the town likelihood of anything at the same level roughly that's a neighbor. So each of these would get an uptick on town likelihood, and so you build up sort of a score similar to how I did for rivers and other things. And it's going to be the same for the forest, right? You don't necessarily build the town right in the thick of the forest. You build it on the border, potentially. So just being near trees increases your likelihood. Being near water sources, so the same thing, it'll be go through and plot the rivers and the lakes, and you know, like if there's a lake here, that's not a place where a town would form, but all along the border of the lake, you know, would be the place where the town would form. So instead of drawing the lake, you draw it into the surrounding, and you decide how far surrounding a particular sample can be to be considered near the lake. And I did the same thing before for fishing. Like, I figured for a certain type of small boat fishermen, they would tend to collect around these shallows, like shallow oceans. So these would be places where net style fishing could be done, and so chances are fishing villages would form here where the water's really shallow, whereas when you have points that border deep ocean or deeper ocean, that's where ships could dock, so it wouldn't take as much to build a harbor here, because you've got deep sea there. You don't have to worry so much about, like here, right? You could just build some docks out here and the ship could pull right up. Whereas over here, the ship would ground itself before it got to the shore. So you calculate all these things and you build a score. I'm trying to wrap up because I got like 5 minutes left, and so you guys can see kind of where we're going. And I'll still be working on this next week. You can guarantee that, because I'll need to plot the rivers and lakes and things, and then we'll start talking about, once you know where towns can form, you kind of know why they would form there. If this turned out to be, in fact, it probably would. So we're near cliffs, we're near bodies of water. We've got a good harbor location here. It may be very likely that a town would form here, for example. And not only do we know that a town might form there, but we know why. We know that probably there would be forestry there. Probably there would be mining there. Probably there would be a seaport there. And so you can sort of know those things and build out how many people would live there, what kind of occupations would they have, that kind of thing. But where it all starts, and I'll go over this again when I continue this next week. Yeah, the spawn location is actually outside of my area. One of the things when I changed the fractal, the spawn location moved. The spawn location used to be over here in this mountains. And so then, this was, I did this because this is where all my rivers are generated for my tests. Actually, the rivers are generated even wider than that. So maybe I could get away with moving things. At any rate, what happens is there are rules that I have in place. I've sort of hacked these out where within the spawn location, within at least a certain distance, a town should form. So what happens is you have all these samples, right? And you say, well, the spawn is here, so we're going to automatically, give 50 points to every, within that radius. I can't remember whether it's half a day's travel or a day's travel. It's wherever, basically what I wanted was if you're standing at the top of the spawn tower, you should be able to look out at the land and see a town in the distance, right? You should know when you first plop into the world, if you don't want to set off immediately into the wilderness, you want to go to the town and buy some stuff and, collect some quests or whatever, you should know where the town is without looking too hard. You'll have a road and stuff too, probably, but at any rate, within less than a day's travel, there should be a town within the spawn. And so you increase the probability and you pick one, right? So out of those, you pick one, and then now you have a basis for if you have a major town here, within a certain distance, there should be no other towns, maybe villages. And so you discount all of those and you start branching out from there. And the idea being on the main guild roads, there should always be within a day's travel someplace to stop for the night. So so within a day's travel, there should be another point of interest, an inn or village or city, and so you start building out from there. Randomly, things can form more often. They tend to form along the coastlines. Then you build roads and connect them all. And so the idea being that most civilization would be near the coastlines, except for where rivers go inland, and you might have villages and things dotting them, but then you would still have plenty of wilderness. This whole area might end up being wilderness where, the only thing you'd find there are ancient ruins and things from old civilizations and stuff like that. Anyway, as I'm wrapping up, and I'll move this out of the way so maybe you guys can still see that URL that's sitting up here a little better. Of course, it's going to cover everything I do. I hope you guys can see that URL up here. I can't see it without looking at my OBS. All right, so as I wrap up, I'm going to give it a minute in case there are any questions about what I talked about today. I think I made some good progress. Talking about random number generation and getting started on this. I'll spend the week kind of hacking these samples together, and so next stream I'll talk about what the samples mean, and we can start maybe putting towns in places and plotting roads and stuff like that, see trade routes and things. If not next week, then the week after. Really what I want to do is for this next phase get world generation nailed down. Even if specific towns aren't generating correctly, I want to know where they are so that that's all in the bag. Thank you everyone for joining and listening to me ramble on for an hour. I hope it was entertaining. Thanks again for all of my patrons. It super means a lot to me right now because the expenses this time of year are horrible. For those who don't know, in America, United States, insurance is crappy, and you have this thing called a deductible that you have to meet before the insurance starts paying for stuff. So it gets very expensive at the beginning of the year before you've met your deductible. Good times. Okay, so let's go. Ha, that is a big question. So, the short answer is that ever since I had written my first computer game and played Dungeons and Dragons, at age 12, 13, messing with adventure games. I played Ultima 3 Exodus. We're talking about back in the day. I always wanted to make computer RPGs, and I always had this vision in my mind for how those should go, and tried, dabbled in it for years. JMonkey Engine, which is the underlying Java game engine that I'm using here, I actually dabbled in that in like 2006 or something. It was still JMonkey Engine version 1. And I've, since the 80s, late 80s, I've been playing with fractal generation, terrain generation, all this different stuff because I wanted to make a game that I could play. And that I could play myself and still not know where everything was going to be. So I always had these ideas, and I'd been working on it, read books, read articles on ecology and where plants should form, planting plans, all this different stuff. I've just been collecting information in my head for years and years, as well as running D&D campaigns, RuneQuest campaigns and stuff. Then tried and failed a couple times because just couldn't get it off the ground. Did a lot of Neverwinter Nights modding back when Neverwinter Nights was still popular. I think I had built kind of a name for myself there as well for the libraries that were reused, Z-Dialog and PG lists and things. And my mod packer tools. At any rate, so at some point I was still, I'd kind of mothballed all this stuff, and then I decided to try this Minecraft thing everyone was talking about. And it turned out one of my friends had a server, and we played on it for like a weekend straight. And I'm like, you know what? I know enough OpenGL that something like this is really easy, to batch those things and generate. So let me go take a look at JMonkey Engine and see what it's going to. Because if all of my RPG ideas, while being sufficiently lowered in graphics quality, I would be able to do a lot more, because you could build houses, you could do all the different things that I always thought would be really cool after playing, the Ultima games. And so that weekend I downloaded JMonkey Engine, went through the tutorials, and it had come a long way since it was 3 alpha at that point, and it come a long way since the last time I used it. And 2 weeks later I had my engine up and running and ready to download for people to try. That was February of 2011, I think. Yeah, February 2011. And then by that April, I had the network version out, and that took all of my time. And so that's sort of where I am. I want to build a game I can play that's got Dungeons and Dragons style elements in it, fantasy role playing, generating as much as I can. It's a super ambitious task, but the nice thing is I feel like if I fall even 25% of my goals, it's going to be a pretty cool game, and you might all enjoy playing it. I hope that answered the question without over-promising too much. And thank you again for joining, and I will catch you guys next time on the weekly live stream. Please join me next week. Thanks.